Hi everyone! Linear equations are simple tools to help solve problems in everyday life. They help provide the basic problem solving skills needed for everything else. So here's a list that contains just some of the uses of linear equations in the real world. We're going to be reviewing over some basic algebra before the next chapter here. So by the end of this review, you should be able to identify slope, intercepts, and equations of lines, determine whether two lines are parallel or perpendicular, identify vertical and horizontal lines, solve systems of linear equations, and graph linear equations. So we're going to start with some concepts from chapter 3, which is a linear equation in two variables. So find an equation of each line with the given slope that passes through the given point. Write the equation in the standard form. So this is the standard form here, ax plus by equals c. And so for number 25 here, we're given a slope and we're given a point. Well, this does not have a slope or a point. So we're going to have to use a different form of an equation in order to write that equation. So let's take a look at this part here. Identify the form of a linear equation in two variables for what form it's written in. So 88, 5x minus 9y equals 11. You can see that's of the standard form, the ax plus by equals c. In 89, y equals 3/4 x minus 1/3. That's the slope-intercept form. That's in the form y equals mx plus b, where m is the slope and b is the y-intercept. And then number 90, y plus 2 equals negative 1/3 parenthesis x minus 2. That's the point-slope form. So y minus the y-coordinate equals the slope times x minus the x-coordinate. And so m is the slope, of course, and there's a point with an x and a y-coordinate, and that's what goes into those parts there. Okay, so we want to talk about those first. Now we can actually build an equation of a line. So for 25, we're given the slope and a point. So I'm going to use that point-slope formula in order to build the equation here. So y minus the y-coordinate, which is the second coordinate in an ordered pair, so negative 5, equals the slope, negative 8, times x minus the x-coordinate of negative 1. So I've got an equation here, but I need to get it in the standard form. So there's a lot of simplification I'm going to have to do. And the first part is to change any subtracting of a negative to plus. And then I'm going to have to distribute this negative 8 here. So on the left side, y plus 1 equals the right side. Negative 8 times x is negative 8x, and negative 8 times 1 is negative 8. So I do want my number terms to be on the same side. That's what that c is, just the constant or number term. So I'm going to opposite 1 from both sides of this equation. Then y equals negative 8x minus 9 altogether. So then the last piece is to make sure that x and y are on the same side. So I'm going to add 8x to both sides of this equation, or this equal sign. Then on the left side, I will have 8x plus y equals the right side. Now there's just negative 9. So this is the standard form because a is a whole number. A has to be a whole number. Remember, that's 0, 1, 2, 3, 4, 5, 6. So no fractions, no negative numbers, and that's perfect. Then for 45, find an equation of a line that's parallel to y equals 5, and it goes through this point, 1, 2. So it's important to remember what parallel means, and parallel means that the two lines have the same slope. So what's the slope of this line? It's a horizontal line, y equals 5. And therefore the slope is 0. There is no rise, so 0 divided by anything is 0. That's the slope for a horizontal line. And so if our line is parallel to this line, that means it has the same slope. So it also has a slope of 0. So I've got a slope of 0 and the point 1, 2. And so if I wanted, I could use the point slope form. So y minus 2 equals 0 times x minus 1. But you'll notice on the right side of this equation, 0 times x is 0, and 0 times negative 1 is 0. So 0 plus 0 is still 0. So on the right side, we only have 0. And so this is an equation of the line, and that's fine. But I can also add 2 to both sides of the equation to get y equals 2. And I can also add a 0x to that side if I wanted standard form. That's okay too. Either way that I write that, those are equivalent equations for a line parallel to y equals 5 that goes through 1, 2. Then we want to identify the appearance of the graph of the equation that's given, determine whether it's vertical, which means straight up and down, horizontal, which means straight across, or sloping, which could be a positive slope or a negative slope, either one. So for 91, y equals 1/2. Anytime you have an equation with just the y variable in the equation, the x is zeroed out, which means that this is a horizontal line and it has a slope of 0. For 92, anytime you have an equation which just has the x variable, that means the y variable has been zeroed out, which gives you a vertical line. And the slope of a vertical line, you can tell that there's no run. So when you divide by 0, what do you get? Undefined. So the slope of all vertical lines are undefined. So 95, we want to write an equation in standard form of a line that contains this point, and it's perpendicular to this line. So we'll have to remember what perpendicular means. And so parallel are lines that have the same slope, right? 2 lines that have the same slope, that's parallel. But perpendicular are 2 lines that have opposite reciprocal slopes. And that is why they form 90-degree angles. So that's what makes 2 lines perpendicular to each other, is they intersect at a 90-degree angle. And that's because they have the opposite reciprocal slopes. Now remember, opposite means positive or negative, and reciprocal means you switch the numerator and denominator. So therefore, a -3 and a positive 1/3 are opposite reciprocal slopes, which would result in perpendicular lines. So let's see, what is the slope of this line here? Y equals 3x minus 1. It's in the slope-intercept form, right? Y equals mx plus b. So we can identify that the slope is 3. That's the coefficient of the x term. So then what is the opposite reciprocal of 3? Well, I have to move that to the denominator, and then I need the opposite. So a -1/3 is going to be the slope of our perpendicular line, and it goes through this point. So let me just use that point slope form. Y minus the y coordinate equals the slope times x minus the x coordinate. So then I want to definitely change the x minus -1 to x plus 1 by that general rule. And then go ahead and distribute the -1/3 on the right side. So -1/3 x and -1/3. Ooh. So then I need to get the number terms on the same side. So I have the constant term. I'm going to add 2 to both sides. And when you're adding 2, that's 2 over 1, because all integers are rational numbers. And then I need to get the common denominator. So I need a denominator of 3 here. And that means that's going to be 6/3. So I want to add a -1/3 and a positive 6/3 together on the right side of this equation here for the constant term. So 6 minus 1 is positive 5/3 altogether. Then we need to get x and y on the same side. So I'm going to add a positive 1/3 x to both sides of the equation. Okay, I'm going to bring it over here. So positive 1/3 x plus y on the left side of the equal sign, and just 5/3 on the right side of the equal sign. This is close to standard form, but it's not quite standard form yet because a has to be a whole number. And 1/3 is not a whole number. So I just need to clear the denominator here. So if I go ahead and multiply by the denominator, 3, then that will clear out that denominator for that term. But I have to multiply 3 to every term in the equation to stay balanced and equivalent. So that's going to be just x and 3y. On the other side, that will cancel out that denominator, leaving just 5. 21, we want to graph this equation, and it's in the slope-intercept form, which makes this really much easier to graph. So we start with the y-intercept. In this case, that's a positive 2. So we've got the x-axis and the y-axis. Where they intersect is the origin here. And that's where we always start when graphing. So starting at the origin, we're going to go up 2. So that's going to be the y-intercept of this line here. And then the slope tells us where to go from there. So a slope of -1/3 means we need to go down 1 unit for every 3 units to the right. So down 1, right 3. We can do that forever. We can also go the other way. If we want to move that negative to the denominator, then we're going to go opposite, so left as we go up. And we can connect those points together to form the line. So connect those together with a straight edge, make that as straight as possible. And don't forget those arrows on the end. Arrows are very important when graphing lines, because those points will continue on that slope trajectory forever. For 22, is the ordered pair a solution of the given equation? So how do I know? Well, this is the x-coordinate and this is the y-coordinate. Let me just put those into the x and y of this equation and see if it's true. So -7 times x, which is -1 here, minus 8 times y equals -9. Okay, so a negative times a negative, that's a positive 7. Negative times a positive is -16. And 7 minus 16 is a difference of 9, where the bigger number is negative. So that's true. So yes, that ordered pair is a solution to that equation. Because it makes it true, it is a point on that line. For 23, find the slope and y-intercept of the given equation. So when the equation is in the standard form, I can't tell what the slope and y-intercept are. What I need to do is I need to solve for y, because when I do that, I can identify the slope and the y-intercept of any linear equation here. So let's do that. Let's go ahead and solve for y. So we're going to opposite the x term here, minus 3x from both sides of this equal sign. So we'll have just the minus 4y on the left. I'll put these in the right order on the right side. So negative 3x first, plus 4. And then I just need to multiply the reciprocal here to get y by itself. So I'm going to divide -4 from every term in this equation in order to get 1y on the left side. So that'll be a positive 3/4 x and a -1 when I simplify those terms. So what's the slope? 3/4. What's the y-intercept? 0, -1. That's the y-intercept of this equation, or this line. 24, we want to find the slope of a line that goes through the 2 points. So we've got the first point here and the second point here. And the slope of 2 points is just the difference of the y over the difference of the x. So that's why I labeled them there. Let's just go ahead and take the difference of the y over the difference of the x. And the order of this doesn't really matter as long as an ordered pair lines up vertically. Perfect. And y must be on top, of course. So that'll actually be 2 plus 6 by the general rule. And 5 minus 5 is 0. So 8 divided by 0, anything divided by 0, is undefined. So that makes this slope undefined. So that line must be vertical. For 28, find an equation of a vertical line that goes through this point. Interesting. We just talked about how a vertical line has a certain type of slope, because in order to build an equation of a line, you have to have either 2 points or a slope and a point. We only have 1 point here. So do we have a slope? Well, that comes from the fact that we know it's a vertical line, so that's undefined. And that actually makes this a little bit more tricky, because I can't exactly put undefined into my slope equation for the equation. So I have to realize that vertical lines only have an x coordinate. So in the equation, I know I'm only going to have x, no y, or 0 y. So what is the x coordinate? Well, if it goes through this point, x has to be 0. X will be 0 on the entire equation here. And 0, 7 is just one of those points. But all of the points have 0 for x. And any number for y. Every number on the number line. So x equals 0. We're into chapter 4 now. So chapter 4 talks about linear equations in 2 variables, but not just one equation, 2 equations, 2 lines. So if you have 2 equations, you're talking about a system of linear equations. So for number 10, solve the system by graphing. And what that means is graph the first line, graph the second line, and see what points they share. Shared points are solutions. So let me start with the first line here. If 3x plus y equals -2, how am I going to graph that? Well, I'm going to solve for y, so I can use the slope-intercept form. So if I subtract 3x from both sides, y equals -3x minus 2. So for this first line here, I'm going to start with the y-intercept of -2. And then the slope tells me down 3 as I go right 1. Or I could go left, but I have to go up 3. And then I'm going to connect those together in the line that continues forever and ever. So then I need to graph the second line. So the second line, y equals -5x. And that's kind of sloppy. There we go. Well, what's the y-intercept? It doesn't have one, which means it's 0, so right on the origin. And we'll go down 5 as we go right 1. Wait, that's going to be the bottom. Or we could go left 1 and up 5. Okay, so we'll graph that line there, connect those together. And does it appear as if those 2 lines share any points? It looks like they share that point right there. So it kind of looks like that point is 1 for x and -5 for y. It looks like that to me. Well, how do I know if that's true? Because I'm kind of guessing here, right? I can check to see if that's a point that's on both of those lines. So the first line, 3x plus y equals -2, let me put those coordinates into that equation and see if it's true. Yep. So that is a point on the first line. Is it a point on the second line? Why am I putting y? Because y is -5 equals -5 times x. And that's true too. So yes, I've proven that that's a solution to the system of equations. It is a point that's shared by both of those lines. For 15, we're going to solve the system by the substitution method. And so the substitution method asks us to solve one of the equations for one of the variables, and then plug that into the other equation. So I'm looking at these equations, 1 and 2. And I could use either one. But number 1, I'm going to solve for x. It's the first thing I see that there's no coefficient, so it's a good variable to solve for. So I'm going to opposite the 3y from both sides. And that's not really fun to have negatives, but then the order doesn't matter. But that's what I get. So x equals -3y minus 3. So now I'm going to take what x is equal to, and I'm going to put that into the second equation instead of x. So it's the second equation, 2 times x, which is -3y minus 3, plus y equals 4. So now the second equation only has the y variable. I can solve for it. So let me get rid of these parentheses by distributing the 2. And then I have like terms I can combine. That's -5y's altogether. Then I want my number terms to be on the same side, so I opposite the 6. Then I have -5y equals 10. And then the multiplication property, I can just divide -5 from both sides to get y equals a -2 for my solution. But that only tells me what y equals. So for this solution, I know y is -2, but I don't know what x is yet. I got to go back over here to the first equation and put in the y that I found, -2. So that'll be a +6 minus 3, which is a +3. And then I want to double check, in these equations to make sure that that's true. So 3 minus 6 is -3, yes. 6 minus 2 is 4, yes. So that definitely works. That's my solution to the equations. For the last part, we just want to answer true or false here. So for number 1, a system of 2 linear equations and 2 variables can have exactly 2 solutions. That doesn't make any sense. Either the system has one solution because you have intersecting lines, no solutions because you have parallel lines that will never touch, or infinitely many solutions, which is all of the same points that the identical lines share. For number 2, although 1, 4 is not a solution of x plus 2y equals 6, it can still be a solution to the system. So you notice the system has that equation, and if 1, 4 is not a solution to one of the equations in the system, it's definitely not a solution to the system, because the solution has to be true for both of the equations in the system. For number 3, if the 2 equations in a system of linear equations are added together and the result is 3 equals 0, which means both variables cancel out additively here, then the system has no solution. And that's definitely true. If you end up with a false statement, then there's no solution. For number 4, if the 2 equations in a system of linear equations are added together and the result is 3x equals 0, then the system has no solution. Well, this is a completely different story because 3x equals 0 still has a variable which I can go ahead and solve for and find a solution to the system. So that's definitely false. There will be a solution, one exact solution to that system. So that kind of summarizes some ideas from chapter 3 and 4. You can always read the textbook to go back and check on anything that seems confusing still. And next we're going to be working with chapter 8, which is a lot of graphing and linear equations, and chapter 9, linear inequalities and absolute value equations and inequalities.